picking up right where we left off. We're going to go to part D here in our examples of just finding these derivatives. A lot of practice with the chain rule in different styles. Part D says f of x equals the natural log of 5x squared. So we want to recognize this as being a composite function. And we want to recognize what is the inside and what is the outside. And we're kind of back to things that are a little bit more familiar to recognize. So here you go. What's inside those parentheses is the inside function. And the outside function is the natural log. Okay, so I left the space blank now. Let's go ahead and find this derivative. Now, when it comes to natural logs, people can get tripped up, so it's really good to point this one out. What's the derivative of the outside here? Well, if you remember, natural log x, its derivative is 1 over x. Now we have something other than just x, right? We've got 5x squared, but it's going to follow the same pattern. Here's how we do it. Whatever we see here gets repeated here. So think of the derivative of natural log as being 1 over, well, 1 over what? Whatever was here. So the derivative of this outside is 1 over 5x squared. And that's the derivative of the outside. This is strange. A lot of students get tripped up with natural log when it comes to the chain rule because the derivative of natural log is kind of different than other derivatives. That's how it goes. Again, whatever you see there, that gets repeated here. So natural log of 5x squared, derivative is 1 over 5x squared. Okay, then we move on, times the derivative of the inside, and well, in this case, it's 10x. And if this was a test or a quiz, you could stop right there in the unsimplified version, although this one's not too bad to simplify, right? An x would cancel, 10 over 5 is 2. You know, you could just leave that as 2 over x. And this is the simplified version. Okay. We're going to do one more of these before moving on to another type of example. Part E, y equals x times the natural log of 1 plus e to the x. Now we're getting a little bit more complicated. We got that natural log again. It'll be good to practice that derivative. But also, there's another rule at play here. And it'd be kind of nice if we were in the classroom together and I could say, okay, so we're going to use chain rule, but there's actually another rule going on. What is it? Okay, so I'll just tell you, of course. So, well, it's the product rule, because aren't we doing x times this natural log? And so you might write like a little dot in between those, right? X times this. So the product rule is really, you might say, is like the bigger picture, the broader rule that's going on. And within that product rule, there's a chain rule. Okay, let's do this together. So how does the product rule work? The product rule says take the derivative of the first thing, which in this case would be 1, multiply it by the second one left alone. So we're just going to copy all of that. Okay, plus leave the first one by itself, and now take the derivative of this natural log 1 plus e to the x. But in order to take that derivative, we need the chain rule. Okay, so let's think. What's the inside and what's the outside? Well, the inside is 1 plus e to the x. The outside is the natural log. So we'll start with the derivative of the natural log. And we just learned, okay, that just means derivative natural log 1 over whatever's inside there. So 1 over 1 plus e to the x. And there's your derivative of the natural log. And we've even copied the g, right? It happens to be copied, underneath there. All right, then we multiply. Now we think, okay, what's the derivative of the inside 1 plus e to the x? Well, the 1 is 0, and the derivative of e to the x is e to the x. So there's your derivative, and this would be the unsimplified version suitable for a test or a quiz. If you wanted the simplified version, well, there's not really a lot to do. You get rid of the 1 times, right? We don't need that. And you could put the x and the e to the x up here in the numerator, x e to the x over 1 plus e to the x. There's really not really all that much, but that would be the simplified version. So again, kind of look back, product rule, right? Derivative of the first, copy the second, plus copy the first, and then this whole thing here, maybe we just kind of do this. That's the derivative of natural log 1 plus e to the x. That whole thing. Okay, let's move on to not just doing a derivative only. Let's take a look at finding the equation of a tangent line. Certainly you will get these sort of questions in homework. Find the equation of the tangent line at x equals 2. F of x equals x squared over 1 minus x to the 4th. Okay. Well, in order to find the equation of the tangent line, of course, we'll need the derivative. We need the slope of the tangent line, which is the derivative, and then we'll plug in the 2. And we also need a point that the tangent line passes through. That's when we plug in 2 to the original function. Let's do the hard part first. Let's find the derivative and then try to plug 2 into that. All right, well, finding this derivative, let's think about what rules would apply. Well, we're going to have a quotient rule, right? We've got a high and a low. And then if you look closely at the low, that is going to need chain rule because we've got, an inside to the 4th. Right? Okay, so here it is, and let's talk through it. There's f prime. There's a lot going on. You notice it's got the quotient rule, so we're just going to think high and low. So quotient rule says f prime of x equals the low. We just copy the low, 1 minus x to the 4th, times d high. D high is x squared, high is x squared, so d high is 2x. Low d high minus high, that is x squared, times d low. Okay, and this is where the chain rule comes in with our d low. Why is this the d low? So the inside is 1 minus x, the outside is the 4th power. So the derivative here, well, the 4 would come down in front, and the power would drop to a 3. And what do we copy inside of that? Just the original g, the original inside, 1 minus x. So the 4 comes down, power drops to a 3, and we just copy that 1 minus x. But then we need to multiply by the derivative of what is inside those parentheses. Well, in this case, it would be negative 1. 0 and derivative of x is 1, so 0 minus 1, negative 1. Okay, so let's recap. So we got low d high minus high d low, and it's all over that low, that whole thing squared. Okay, let's begin to simplify. And now, well, we have to simplify because we're doing more than just finding a derivative. So we'll just start with the simple stuff. Let's see, the negative would multiply there, so it becomes a plus, and we can move the 4 in front of the x squared. That's probably a bit more natural. Also, the 2x, we can move the 2x. Usually we put that in front of a quantity like that. So 2x, quantity 1 minus x to the fourth, plus 4x squared, 1 minus x to the third. And the denominator, well, an exponent raised to an exponent, and we multiply them. So 4 times 2 gives us 1 minus x to the eighth. Now it turns out we can keep simplifying. Notice that each one of our terms has has a 1 minus x to the third. So we could think about factoring 1 minus x to the third out from the numerator and then canceling with 1 minus x to the third in the denominator. And that's what we've done here. Let's cancel 1 minus x to the third, or you can even think of it as canceling it from each term. So canceling 1 minus x to the third here just leaves us 1 minus x to the first. Here, well, the whole thing drops away. And canceling 1 minus x to the third there would make the power drop to a 5. So this is a more simplified version. And then we could even distribute that 2x and then combine some like terms, and we really get it down nice and simple right there. So let's see, how did this work? So 2x times 1 is the 2x. 2x times negative x, negative 2x squared. But then we're going to add 4x squared, so that gets us to positive 2x squared, and then our denominator is the same. Okay, so we got our simplified version of our derivative right there. Let me pick it up on the next page. What do we do once we have the derivative? That was a lot of work. We still need to plug in 2, right? We're trying to get the slope of the tangent line at 2. Or the equation of the tangent line at 2, actually. So we'll plug 2 into our derivative. Boom, boom, boom. Plug it into all the x's. Turns out, let's see, this is going to be 4 plus 8 will be 12. And that's negative 1 to the fifth is negative 1. So 12 over negative 1, the slope of our tangent line is negative 12. And we can just maybe write m equals negative 12. That's a little bit easier to think of it that way. And of course, we need the point that the line passes through. So we have to plug 2 back into the original function. And so it's well off the screen by now, but hopefully you wrote it. That guy right there. 2 squared over 1 minus 2 to the fourth. Well, that's 4. That's negative 1 to the fourth power would be positive 1. So 4 over 1 is 4. So the point is 2 comma 4. So we have our slope, we have our point. And we can set up our point slope form. Y minus 4 equals negative 12 times x minus 2. Put that into y equals mx plus b form. Let's see, that'd be negative 12x plus 24. But then we add another 4, so it's plus 28. Y equals negative 12x plus 28. That's the equation of our tangent line. Came out pretty nice, actually. Okay. Now, kind of reflecting on this problem, even going back to the original derivative, if we're trying to find the equation of the tangent line, it was good practice, and it really made it a lot easier to plug in the simplified version. But you know what the truth is? We could have plugged in this 2 to the unsimplified version, couldn't we? Couldn't we have plugged in 2 and 2 and 2 and 2 and 2 and still gotten our slope to be negative 12? Yeah, we could have. We could have. Although in this case, I think the chances of making like a miscalculation by plugging in 2 into this unsimplified version might be just as big or even bigger than just going through the simplification steps, at least some of the simplification. Maybe you only get it down to here, or maybe even just to here before you plug that number in. At the end of the day, it doesn't have to be simplified in this problem, right? So long as we get the slope correct as negative 12, then we really didn't have to simplify all the way. But it's a good practice anyway. Okay. I've got one more example before we close this section. Just something that didn't come up in any of the other examples before, and so it's a good idea to point it out now. How about something, we'll just take the derivative here. How about the derivative of y equals the quantity e to the 5x plus 2, all raised to the third? Okay, why am I saving this one for last? So it turns out the chain rule, it doesn't have to have only 2 layers. There can be more than 2 layers. This one actually has 3. So if you think, well, how are there 3 layers going on? So the outermost layer is that third power. It's outside the parentheses, so it's on the very outside. But then as we look to what's inside, we actually see there's something inside the e. So that 5x, and I can just point it out clearly there, that's the, you might say, the innermost, and this whole thing, the e to the 5x plus 2, is like a middle layer. So there's an inner, a middle, and an outer. And again, that's not immediately obvious, and we might not be expecting that if I never pointed it out, that there might be more than 2 layers to a chain rule derivative. But hopefully that makes sense why, right? So the variable is the innermost, but that is inside the power of e. But even that e, well, we've got to add 2 to it, but even more so, that is inside this third power. So innermost, middle, and the middle would include the plus 2, and then that whole thing is inside the cube. So let's see what our derivative would look like, and maybe I'll erase this. We'll walk through it like we were doing before. I think that's better for these problems. Okay, so y prime. Start with the outside, and we work our way in. So the derivative of the cube, right? We drop the 3 all the way down in front, and then it becomes a square. But what do we copy here? That entire middle. E to the 5x plus 2. So the 3 comes down, becomes a 2 there, all right, and then everything else gets copied. All right, so that's the first link in the chain. Then we got to move to the derivative of the middle layer. Okay, well, the derivative of e is itself, so that gets copied, and even the 5x gets copied. The derivative of the plus 2 is 0, so this is the derivative of the middle layer. And then we multiply one more time, and we go to the very inside. The derivative of the 5x is 5. So there we are, the 3 links in the chain. So if this was a quiz or a test, you could stop right there. Or it wouldn't be too hard to simplify. Why is that? Well, we could say 5 times 3, and then we can maybe move that e to the 5x in the front, and then we can put the e to the 5x plus 2 squared like on the end. That looks like we're used to seeing things. So there you go. A chain rule with 3 layers. Of course, there could be more. I don't think you'll get any more than 3 layers in the homework. I could be mistaken. But, be prepared for those sorts of things. Okay, that's it for this section, and hope to see some of you guys in office hours.